All right, y'all. Welcome back. Today we are going to talk about 2.6. So the last class with Miss Davenport, you all discussed 2.5, which was completing the square. Today we're going to talk about another way to solve quadratics, which is the quadratic formula. This one will work for any problem that you ever wanted to do. So if you completely forgot how to factor, or you forgot how to do completing the square, you forgot how to solve using square roots, we can use the quadratic formula. Okay. This is page 102 and 103 in your workbook in section 2.6. And then right here is the quadratic formula. So it looks a little bit confusing, right? There's a lot going on there. But take a second and write that down. And you'll see once we do a couple problems that it's not as bad as it kind of looks. Okay. Basically, we just need to find the numbers and then we just plug them in and do the order of operations. And then we'll have our answer. Okay. So let's start this first problem. It says solve using the quadratic formula. Now, you don't have to memorize this formula, but there's a couple of videos that you're going to watch. There's actually one video that you're going to watch on our modules that will probably get stuck in your head, and you'll be able to remember this kind of on your own. If we were in class, I would play like 4 or 5 different songs, and we're going to watch another one in class. But there's a couple of songs that will help you remember this. So don't worry about if you can't memorize it, but I don't think you all will have a problem. All right. So the first thing we're going to do, this is a quadratic because it has a square. Okay, so what we need to do is we need to pick out what A, B, and C are. Now, A is always in front of the x squared, B is always in front of just the x, and C is always just the constant. So once we figure out what A, B, and C are, we're just going to plug them into this formula wherever they go. All right, so if we were to plug them in, x equals negative B, B is 6, so that would be negative 6 plus or minus the square root. Okay, now we plug in b squared, which we just said was 6. 6 squared minus 4, that's where that 4 comes from, times a times c. A is 2, c is 3. All over 2 times a, and a is 2 again. Okay, so all I did was plug those numbers into that formula. And you'll notice every number that I put it in parentheses. All right, that helps me remember those are the numbers that I put in. All right, now we're just going to work this thing out. So the first thing we need to do is all the stuff under the radical, under the square root. I'm going to keep everything else the same. So this negative 6 is going to stay negative 6. And then I'm going to simplify in here. So 6 squared is 36. And then negative 4 times 2 is negative 8. And negative 8 times 3 is negative 24. All over 2 times 2 is 4. So I just started with simplifying underneath the radical. All right. Now we're going to do the subtraction problem. So that would become negative 6 square root of 12 over 4. All right. Now 12 isn't a perfect square, but there's a perfect square that goes into it. So I could simplify it down a little bit. Draw a little line right here so I don't go into the other one. Okay. So I know 12 is not a perfect square, but let's see if we can break it down. So 12 is actually the same thing as 4 times 3. Okay, so I split up the 12 into 4 times 3. That's a multiply, not 4.3. And then the square root of 4, hopefully we all know, is 2. So this becomes 2 square root of 3 over 4. All right? So I split up the 12 into 4 times 3, and then the square root of 4 gave me the 2 that I put in front. So once I have that, the last step is to see if we can simplify. And if you look at all these numbers in front, the negative 6, the 2, and the 4, right? I could divide all of those by 2 because they're all even numbers. So if I did that, negative 6 divided by 2 is negative 3, plus or minus. The 2 goes away because 2 divided by 2 is 1. So square root of 3 over 4 divided by 2 is 2. And we are finished. Okay, so we basically did what we've been doing this whole chapter, right, with the square roots and the radicals and simplifying the radicals. Just now it's in the big quadratic formula equation. Okay? All right, the second problem. We're going to do the exact same thing. All right, we're going to do the exact same thing. It's just different numbers now. So a is always in front of x squared, b is in front of x, c doesn't have a variable. So I plug it all in. X equals negative b, but b is already negative 2. So negative negative 2 plus or minus the square root of b squared minus 4. A is 3, c is 7, all over 2a, which is 3. Again, I just plugged all these numbers, a, b, and c, into this equation. All right? And now we need to simplify it. So these two negatives become a positive. Square root. Negative 2 squared, you can use your calculator to help you out, is 4. Negative 4 times 3 is negative 12. Negative 12 times 7 is negative 84. All over 2 times 3 is 6. Okay, so now we need to simplify underneath the radical. So 4 minus 84. So that's 2 plus or minus the square root of negative 80 all over 6. And this is what we talked about in section 2.4. Notice there's a negative underneath the square root. So that means when we're done, our answer has to have an I in it. Okay, there must be an I because there's a negative under the square root. So we're going to do 80 just like we did 12. Let's try to split it up. So if we split it up, negative 80 is the same thing as negative 16 times 5. That's negative 16 all over 6. Okay, so negative 80 is the same thing as negative 16 times 5. So now that we've split it up, the square root of negative 16, the square root of 16 is 4, but since it's negative, I pull out a 4i, and the 5 just stays where it was. Okay, so that's the only difference. Since it was negative, I have to put an I along with that 4. Okay? And then we do exactly what we did in the last step. Look at the numbers in front. 2, 4, and 6. They're all even again. So I could divide all of those by 2. 2 divided by 2 is just 1. 1 plus or minus. 4 divided by 2 is 2i. The 5 isn't going to change. And then 6 divided by 2 is 3. There's my final answer. Okay? So there's a part of this quadratic formula that's really, really important, and it's called the discriminant. Okay? In this first problem, the discriminant was 12. In the second problem, the discriminant is negative 80. All right? And that tells us what kind of answers we should end up with when we're done. All right? So skip example 2. All right, we're going to come down here to example 3. So now we're going to talk about the discriminant. The discriminant is the part of the quadratic formula that is under the square root. So you'll notice b squared minus 4ac is exactly what's underneath here, b squared minus 4ac. Okay, so it's part of the quadratic formula. But what it does is it gives us, it tells us what our answer should look like when we're done. So if the discriminant is a positive number, you're going to have two, this should say real solutions. Okay, you're going to have two real solutions. If the discriminant is negative, you're going to have two imaginary solutions. And if the discriminant is 0, you're going to have only one solution. All right? So if the discriminant is positive, you're going to have two real solutions, which we saw right here. That is a positive 12. So we had two real answers. Real meaning there's no I in it. Okay, there's no I in our final answer. If the discriminant is negative, you have two imaginary solutions, which is exactly what we have right here. I have one plus 2i and one minus 2i. So there's my two answers, and they have I in it, so it's imaginary. All right. So for example 3, all we want to do is find the discriminant and state how many solutions it will have. Okay. So we're going to do the same thing we did before. We're going to pick out A, B, and C. So A is always in front of x squared. B is always in front of x. C is always by itself. But now I don't need to do the whole formula because it just wants to know the nature, meaning the types of solutions. So it wants to know, are they real or imaginary when we solve it? And how many of them will there be? All right. So all we have to do is the discriminant. So b squared minus 4ac. B is 8. So 8 squared minus 4. A is 16. C is 1. So all I did was plug A, B, and C into the discriminant. Okay? Because it doesn't want the whole answer. It just wants to know what are the answers going to look like when we do solve it. So we solve this thing. 8 squared, 8 times 8, 64. Negative 4 times 16 would be minus 64. And then times 1 is still minus 64. So 64 minus 64, the discriminant equals 0. Since the discriminant is 0, that means we are going to have one solution to this problem. If we were to solve this, now we're not going to, but if we solved this, we would only get one answer. There wouldn't be two answers to this problem. Okay, there would just be one. Because this number would be a 0, and the square root of 0 is just 0, so it kind of goes away. Okay, the 0 just goes away. All right, actually just noticed up here I forgot to put the plus or minus in between them. Okay, I forgot the plus or minus in that problem. All right, let's do the same thing for B, as in boy. Remember, A is in front of the x squared, B is in front of the x, C is by itself. So we plug it all in. B squared would be, negative 5 squared minus 4ac. Minus 4 times a is 2 times c is 6. So now we just do our math, right? We do exponents first. So negative 5 squared is 25. Negative 4 times 2 is negative 8. Negative 8 times 6 is negative 48. 25 minus 48 is negative 23. So we got a discriminant that is negative. If the discriminant is negative, that means we're going to have two imaginary solutions. Okay? Two imaginary solutions. All right, so that is the quadratic formula and the discriminant. I'm going to be honest with you. This is probably my favorite way to do them besides factoring, right? If I can't factor, I usually jump right to this. I don't do completing the square. It's not my favorite. I prefer to do this method over completing the square. Okay, this one makes a whole lot more sense to me than crazy completing the square. All right, but those are our notes for 2.6. Okay, please make sure you submit a picture of it to Canvas. And then finish your assignment, which is actually going to be a quick little project. Okay, thank you all.